Okay, in this video, we'll cover how to configure the OCS to use the downloadable protocols to set up communications for various device applications. This will be a general overview of the downloadable protocol configuration using Modbus Client version 4.05 as an example. First of all, let me go to the website. And once you're on the website, if you use the menu, which is viewable here on the small screen, on a larger screen it'll be hidden. You'll go to Support, Downloads, and Support Files. Here you'll find all the OCS protocols that are available for download. Now bear in mind, not necessarily all the protocols are listed here on the website. If there happens to be one that you're looking for that's not listed, contact tech support and we'll help you out with that. Additionally, you may want to contact tech support before downloading a certain protocol just to make sure that it is supported by your OCS. Now, keep in mind also that some of these protocols are preloaded in Cscape by default. Also keep in mind that it may require updated firmware or even new version of Cscape to operate properly. So once you've downloaded the protocol, the next thing you're going to want to do is go to your C drive, Program Files, x86 folder, and select the version of Cscape you're using. In general terms, it'll be Cscape. On my computer, I'm using Service Pack 3.5, and there'll be two different folders here. One for the Ethernet protocols, which is the Ethernet protocol. And these are the protocols that are currently loaded on my computer. And then there's a protocol folder for the serial protocols. So once you've downloaded the protocols from our website, you'll want to put those protocol files in the appropriate folder on your C drive. Then once you open up Cscape, those protocols become available to you in the configuration. Now let's get into Cscape and go through an example of setting up one of the downloadable protocols. Now there's two places that you can configure the protocol. One of them is under controller hardware configuration. And if you're configuring it for Ethernet, you would select the LAN 1 configuration. And this is where you'd put in your IP address that you're going to be using for LAN. And in the downloadable protocol section, you would select your appropriate protocol. In this example, I'm going to be going through Modbus Client version 4.05 in the 3.5 version of Cscape. Just quickly, I'll show you the other place that you can go to configure protocols is in Programs and Protocol Configuration. Now from here, you'll see that there's both the serial protocol section and the Ethernet section all listed here. So let's get started here. I've already got a OCS selected here. I'm using the XL4 Model 6. So first thing I'm going to want to do to configure my protocol is I've selected the Modbus Client version 4.05. and we'll want to set up the network. So under the network section, the min-max port ID and keep alive time, you generally leave these left at the default settings. The protocol will need to be selected for your application, the TCP/IP or UDP. For this example, I'm just going to leave it at Modbus TCP/IP. Retries, we suggest 1 or 2 is usually sufficient for most applications. The timeout, the default value is 10,000. Now you're probably not going to want that high a value. We generally started out at 1,000. In the update scan section, the update interval, we generally recommend leaving it at 0. You can put a value in there, but it does slow the network down somewhat if you put a time in there. The update interval set to 0 will basically indicate, it will give you a time that it takes the transaction to occur that you have configured. The reacquire time, again, this is by default set at 100,000 milliseconds. And again, we generally started out at a much lower value, around 10,000. You can go much lower than that. 3 to 8,000 tends to work rather well for most applications. There is a manual triggering selection here. For most cases, automatic works the best, but you may have an application that you may need to trigger it. The master ID address is not used in this case. Disable network. This is a new feature starting in Service Pack 3. With the correct firmware, you can disable the protocol using this register. So if you want to use that, it's available. Status register, we highly suggest you configure a status register. This is very helpful in troubleshooting problems with the communications. It's best utilized by assigning a register, as I did. I'm going to assign it to R1000. Keep in mind, this is a 4x32, so there are 432 registers available to you, and we'll go over each one of those here in a second. So the best thing to do is to set up one screen on your OCS with these registers that you're going to assign, the 4. So in this case, it'll be R1000, R1002, R1004, and R1006. And it's best to set those up on your screen so that you can utilize that to troubleshoot any communication problems. Now, if we look in help, protocol help here, this gives you basic overview of what we're going through right now, the general protocol configuration. And it'll give you information on the register mapping. It will give you, let's see, let me get down here to the, it'll give you pinouts for all the connections. And here we have the network communication errors. These are the registers that were just assigned for the status register. So the first register, R1000 that I assigned, it will be the update interval exceeded count. Now I've set my time to 0. So it's going to give me the time, transaction scan time is what it's going to give me. If you put any other value in there, it will give you the exceeded count. Register R1002 is going to give you no response count. R1004 will be the corrupt response count, and R1006 will be the valid response count. And that's the most important one, in that you can see when you have a good connection, that will continually increment. Additionally, when we get to the device status register, the error codes are listed here for that. And once again, we highly recommend you put that on your screen somewhere where you can utilize it to troubleshoot any problems you may have with communications. So that takes care of the network configuration. We'll click OK to that, and we'll go to the device. Now here we'll add a device, and I'm just going to simply call it device 1. Target IP address, since we're using LAN, you're going to give it a register for the IP. So I'm going to use 2000. Now you can put an IP address in there also. Target port 502, that's generally going to stay at 502. In the next section, device options, If 32-bit data is being used, you may need to select the swap words or a single register request depending on how data is transmitted. Then select device type addressing to be used. So 32-bit addressing schemes are determined by the slave device. So keep that in mind. The device type, there's several different addressing available. Generic decimal, generic hexadecimal addressing, native addressing, which is mainly for Horner-to-Horner devices, and then of course the Modicon 5-digit and 6-digit addressing is available. Here again, there's a disable device register available for your use. Let's say you have 2 or more devices configured. You can select those devices and disable them. Say you're having a problem or something, you can disable one and the others will still work. Status enable, this again, I'm going to assign 1008 to this, and I highly suggest that you put it on your screen somewhere to be used with the information that I showed you in the protocol help. So there you have the device configuration, just basic configuration. Now I've left it at generic decimal addressing, but once again, you can use whatever addressing is appropriate for your application. So I'll hit OK, and then we'll go on to the scan list. Here again, I'm just going to add one line here. It'll bring up the device. If you have more than one device, you'll be able to select which device you want to configure the scan list for. The device register, you're going to need to look on your slave device and see how the registers are set up for that device. The mapping, in this case, I'm going to just use since we're using the generic, I'm going to use a similar address for another Horner device, which would be 3006. Now, it will give you a list here of what you can and cannot do here. You can read write, and it'll give you the codes, and you can select your register here. So 3006, and then it appropriately puts it in the blank the way it wants it. So it's a read write at register 3006. And I'm going to use a length of 1. That's one 16-bit register. Now, if I needed 32-bit, I could, in some cases, select a 32-bit access, or just make it a length of 2, depending on, again, your slave device on how it's sending the data. The local register, that's the register on my master device that I want to put the data into. So I'm going to assign, say, register 4000, and it's going to be a pulled read in this case. I could make it a pulled read write. I'm just going to leave it at pulled read. I'll hit OK. And there you have the configuration of one of the downloadable protocols. Okay, I've configured a serial Modbus downloadable protocol here to demonstrate the use of the status register to help confirm communications and aid in troubleshooting problems when they occur. I will also show you the use of the disabled registers in CScape 9.9 Service Pack 3 and above for the network and device. For this to work, the controller will also need to be running 15.40 firmware. I've configured a smart mod using the MJ2 serial port using Modbus Master version 4.05 in CScape 9.9 Service Pack 3. In my network, I have configured my controller to communicate with the smart mod and assign the disable register and status register. I have also done this for the device, as you can see here.
Very loud.
I have placed these registers in my watch window, and as you can see, I already have it running. Please note I have my update interval set to 0 in configuration, so this is showing me the actual scan time for the transaction in the first register. And the fourth status register is showing an incrementing number indicating that the communications is working. The second and third status registers are not incrementing and should be 0 ideally. The device register also shows 0, indicating there is no problem. Now, if I disconnect the cable from the controller, you can see the first register and the fourth register stops, and the second register now indicates no response counts. The device register also indicates at 129 that a timeout has occurred. Reconnecting the cable restores communications, as you can see. The disable registers, as mentioned, can be used to stop and start the communications. This will not give you an error. It just simply turns the communications on and off. And as you can see from my logic here, you can also put this information from the watch window onto your screens so that you can visually see it from your screens.